this here is your you tries it for even and odd functions. Don't graph it. I want to see if you can do this algebraically. So try these three functions, test them algebraically to see if they're even, odd, or neither. And remember, to test it, you're going to plug in negative x into the function and see if the sign changes for every term. Did you pause the video? Okay, so you're back now. We're going to look at A. When we plug in f of negative x, we plug negative x into f, we get 2 over negative x squared. Oops. So that would be 2 over, what's negative x times negative x? That's positive x squared. Is that the same thing as f of x? You betcha. So it looks exactly the same. If you plug in the negative, you get the same thing back. That's an even function. What does that look like on the graph? They're saying that symmetric with respect to the y-axis, Ms. Harris. It's symmetric across the y-axis. All right, let's try B. When I plug in a negative x to this one, I get 4 times the square root of negative x. Well, can I take that negative out of the square root sign? No, we cannot do that, right? In fact, the square root of a negative number becomes what? An imaginary number, right? So this is not going to work. And so does it look exactly like g of x? No, it does not. Does it look exactly the opposite of g of x? No, because the negative sign's not out here. So this is a none of the above, a neither. Neither even nor odd. All right, let's look at C. For C, if we plug in a negative x, we get negative x to the 5th times negative 2 times negative x cubed plus a negative x. Well, negative x to the 5th. Negative to any odd power is going to be what? Hopefully you say negative. So negative times negative is positive, times the 3rd negative makes it negative, times the 4th negative makes it positive. Positive times the 5th negative would be negative. So we got negative x to the 5th. Here I've got 3 negatives. 3 negatives will end up being negative x cubed times negative 2 would be positive 2x cubed. And this positive times negative is going to be negative x. Is this guy exactly the opposite of h of x? Are those signs flipped for every term? So here's a positive becomes negative. Check. Negative becomes positive. Check. Positive becomes negative. Check. All terms change signs. So it is odd, which means it's symmetric about what? Hopefully you're saying the origin, Miss Harris. So that is even, odd, or neither. Now I promised you I'd tell you a little trick. What would happen to this guy if I added, say, I don't know, anything that's got an even exponent to it? So what if we made this x squared, and now I add an even exponent? When you raise that negative to an even, what happens? It becomes positive x squared. Uh-oh, now this term didn't change because it's got an even exponent. So the trick here, the easy way to think about this, is if all of your exponents are odd, it's going to be an odd function, but every exponent in there has to be odd. If all of your exponents are even, it's going to be an even function. If you have some that are odd and some that are even, and here's another odd one, if you have odd things in the same problem, it is going to be none of the above. And then the last thing I wanted to point out would be, what about if you have a constant, Miss Harris? What happens if I add a 3 there? Is that going to change it? Yes, because remember, if you're plugging in negative x to this guy, well, this doesn't have an x, so that will actually stay 3 because there's no negative, there's not an x in there to change the sign. So this guy would become neither. For odds, for evens, though, it doesn't mess with it. You can think of 3 as being 3 times x to the 0 power, and where we consider 0 more of an even number than an odd. So it's kind of a trick if it helps you, especially if there's not a constant in there. If you see all odd exponents, it's going to end up being an odd function. If it's all even exponents, it's going to end up being an even function. And I think that's kind of where we get the name of odd function versus even function. And hopefully that helps you figure it out. You're still going to have to prove it to me algebraically on your quiz, but hopefully that will help you get going in the right direction.